everyone, back at it here with Unit 4, Analytical Trigonometry. Now we're going to talk about the Law of Cosines. So, when do we use the Law of Cosines? Well, if you want me to be honest, when we can't use the Law of Sines first. So remember, the Law of Sines is used anytime we know an angle and the side across from it. So in our setup, we know both A's, both B's, or both C's. So as long as we know an angle and the side across from it, we could always go to the Law of Sines and make the problem fairly easy. But there are two scenarios where you don't know both an angle and the side across from it, and that is where the Law of Cosines is used. So the first scenario is if you know all three sides. We call that side, side, side. So obviously, if we only know the three sides, we don't know any angles. And if we don't know any angles, then we can't jump and use the Law of Sines. So we've got to use the Law of Cosines first. The second scenario is side, angle, side. And in this scenario, once again, I don't know both an angle and the side across from it. And that's where, again, the Law of Sines cannot be used. So I can't emphasize enough. If you do know the angle and the side across from it, doesn't matter any of the three, then Law of Sines makes life pretty easy. Law of Cosines is going to be needed in these two cases where you draw your picture and unfortunately you just don't know that magic ratio, the Law of Sines, so you got to do something else, and this is where we have the Law of Cosines. So here are the three, it actually should be the laws of cosine, but it's called the Law of Cosine, whatever, but there are three laws. Now they're all pretty much the same, but they do have something in common, and I want to emphasize this. So here's our setup. Don't forget the setup where we use capital letters for angles and lowercase letters for sides. So here's that setup. And the Law of Sines, there's three of them. And you can read them here. Now, they are kind of similar, right? It all depends the sides that you know, right? So, for example, if I know A and B, then maybe I want to go and use this one to solve for C, because I know A, I know B, I know A, I know B, right? If I know A and C, then I'm going to use this middle one, where I know A and C, and then I can find B, and so forth. So these are the different laws of cosines. They are very, very similar. The one thing I do want to emphasize is that whatever side is alone on the left is the angle that we use. B, B, C, C. Now listen, I would recommend having a cheat sheet with these on it. I would encourage you to use it. I'm not asking to memorize these. But the good news is you're not going to use all three of them. You're only going to use one of them based on what's given to you. So which one to use is a very common question. So I can't emphasize enough, it's based on what is given to you that will determine which one you need to use. Now I will say this, in the side, side, side case, you can find any angle you want. So let me go back to the rules real quick. If I know both, or if I know all A, B, and C, then technically I could use any one of these. And I could find angle A, or I could find angle B, or I could find angle C. But I do have to say this. This is really the only one thing you have to memorize. Is that in the side, side, side scenario, you need to find the biggest angle first. So technically you could pick, but I'm just telling you, sometimes the best thing is to listen. You need to find the biggest angle first. Now, how are you supposed to know which one's the biggest angle? Well, we'll go back to geometry. Whatever angle is across from the biggest side is going to be the biggest angle. That's a theorem that you should have learned in geometry. So look at your three sides. Whatever one's the biggest, let's say it's A, then find angle A first. Or if B is the biggest, find angle B first. And we're going to start right off with an example of that. So here's our first example. And even though I don't really need to draw a picture that much in this one, I'm still going to draw a picture because it does help me understand it. So A, B, B, C, C. I know B is 19, I know C is 14, and I know A is 8. All right, so I can find any angles, right? Using the Law of Cosines, I can find any angles. Which angle do I find first? Well, again, I'm telling you right now, you got to find the biggest. So since side B is the biggest at 19, I want to find angle B first and foremost. So I'm going to use the cosine formula that has the angle B at the end, which means it starts with B. So I'm going to use the one that's B squared equals A squared plus C squared minus 2 times A times C times cosine of angle B. Now, I have these memorized because I've been using them for way too many years, But again, I encourage you to use your cheat sheet to make sure you get that right. Again, right here, I'm using that middle one, very simple. Just note, again, take the time to look at these, is whatever side you're solving for, or whatever side you know on the left here, in this case B, it's not used on the right side alone. So again, the other sides A and C are used. And at this point, you literally just play fill in the blanks. Like, this is really just basically an algebra problem for the most part once you know the formula to use. So I'm just going to fill in the blanks. 19 squared equals 8 squared plus 14 squared minus 2 times 8 times 14 times cosine of B. So once again, I do have 3 terms. I have 8 squared, I have 14 squared, and remember, this entire thing is a term. Terms are anything separated by minus and plus signs, so I have 3 total terms. So at this point, you're going to go to your calculator to kind of start solving this. Take your time. You don't want to make a silly mistake. 19 squared is 361. 8 squared is 64. 14 squared is 196. And then I'm actually going to figure all this out right now. 2 times 8 times 14 is negative, don't forget the minus sign, 224 times cosine of B. All right, so I just did a little bit of math there to figure out, to kind of start to clean this up. Now, again, I'm trying to solve, this actually goes back to being a trig equation, right? I'm trying to solve for cosine of B. So I'm going to subtract the 64. I'm going to subtract the 196. So 361 minus 64 minus 196 is 101. So I have 101 equals negative 224 times cosine of B. Now I have to stop right here and put a big red flag up because I can't tell how many kids say, oh, add the 224 to the other side. No, that is not a 224. It looks, it smells, it may even taste like a 224. It's not. It's a 224 times cosine of B. So we don't get rid of negative 224 by adding, we get rid of it by dividing, because again, I'm trying to solve for cosine. So the opposite of multiplication is division. So I get 101 divided by negative 224 equals cosine of B. Now, how do I find angle B? You guessed it. I know you're all ready. You're saying it in your minds. I can hear you saying it. Pull the old switcheroo. B equals the inverse cosine of 101 divided by negative 224. And again, I'm using that fraction to try to avoid any kind of rounding. I want to be as exact as possible. Please make sure you're in degree mode on your calculator. Anytime you're working with triangles, we are working with degrees. So I'm going to do the old cosine inverse. 101 divided by negative 224. Close that parenthesis. And there we go. 116 point, well, if I round it, it's 116.80. Actually, if you do want 3 decimals, it'd be 116.801. But I'll go with 2 decimals. So we get 116.80 degrees. All right, so now I have found angle B. What do I do next? Well, I'll be honest. You could use the law of cosines again to find A or C. You really could. But I'm actually going to do something that I think is actually easier, because I think using the law of cosines is easy, but again, it does take, look, it took me about 5 or 6 steps there. I'm actually going to go ahead and use the law of sines, because now that I do know both an angle B and side B, I could use the law of sines. Now, I only have to do one angle, because if I find A, then I could find C, because it's just geometry. All the angles of a triangle add up to 180. So let's see here. So sine of 116.80 divided by 19 is my magic ratio. So let me go ahead and find that magic ratio. So I will say this, anytime you have a law of cosine problems, you're typically going to also have to use the law of sines. Make sure you close that parenthesis before dividing by the 19. And we get 0.04, well, if you round that correctly, 0.0470. 0.0470. Okay, now that I know the magic ratio, it's really up to you. Let's find A. So I know that sine of angle A divided by little a, 8, is the exact same ratio. So I'm going to multiply both sides by 8 to cancel out the division of 8. And then again, I know you're all whispered in your head, and you might even be turning around. Pull the old switcheroo. A is going to be the inverse sine of 0.0407 times 8. But check out what I do on my calculator for accuracy purposes. I'm going to do sine inverse, and I'm going to do 8 times, but I'm going to go and grab all those decimals. I'm not just going to use 0.0470. I'll be honest, guys, listen, you could just use the decimal 0.0470, but I try to be a little bit more exact. And I actually just realized I wrote 0.0407 on my paper, so I'm going to correct that in a second here. All right, and I get 22.08 degrees. 22.08 degrees. So again, I do need to write this as 0.0470. Sorry about that. Same thing here. So sorry. But again, this actually, I mean, I obviously didn't do that on purpose. I can't even try to pretend. But it does bring up a good point that even if you do like write it wrong on your paper, if you go to your calculator and do the copy paste using all the decimals, then you're still going to get the right answer. And at this point, once you know two angles, come on, it's pretty easy to find the third. Take 180 total degrees in a triangle, subtract away angle B, 116.80, subtract away angle A, 22.08, and we get the remaining angle C, 41.12 degrees. So I don't even have to show any work for that, 41.12 degrees, angle C. Very awesome. Now, I will say this. I have mentioned several times that you have to find the biggest angle first. Listen, there's a lot of problems where it doesn't matter. But there just are some, I don't know why, right? I'm a math teacher, but I don't want to get into too many technical things here in this video. There are some reasons why it doesn't work if you don't find the biggest angle first, okay? In most problems it does. But I've just seen some weird problems where you get something funky happening. So again, to avoid any kind of weirdness, find the big angle first and you're always good to go. So that's an easy example of side, side, side. All right, let's look at another example here. Now, when you first look at this problem, I do notice right away, even without a picture, I do notice that I don't know both A's, I don't know both B's, I don't know both C's. I'm going to have to use the law of cosines. But let's just make sure that we draw a picture of this because some kids will look at this as ASS, angle side, side. And if you remember from the law of sines video, angle side, side problems create a little bit of a havoc. But don't be fooled. This is not angle side, side. It's not. And if you're like, yes, it is, angle side, side. No, just listen to me. Draw a picture. It's worth 1,000 words. We know the angle A is 115 degrees. We know little b is 15. And we know little c is 10. So this is side, angle, side. Look, let me highlight. Side, angle, side. This is not an ASS problem that's going to cause a little bit of headache. And that's the good thing. That's why drawing a picture helps you realize, oh, okay, yeah. If I gave you A, C, and A, then that would be angle side, side, but this is not. So that's actually good news. All right, so what do I do here? Well, Well, I'm going to find little a first. Here's why. I cannot find B or C. Go back to the rules. I cannot find angle B. Why? Because if I want to find angle B, I need to know all three sides. And I don't. I only know two of them. I cannot find angle C. Why? Because I need to know all three sides. So the only thing I could actually find right now is angle A. Little a. So I'm actually going to use the very, very first formula. A squared equals B squared plus C squared minus 2 times B times C times cosine of angle A. Why am I doing this? Because this is the only formula where of all the variables, I know 3 of them. If I try to use the second or third formula, I don't know enough. I need to know A, right? If you're going to use either one of these second 2 formulas, I need to know A. And guess what? I don't know A. So that's the thing I'm going to find first. All right. Now, I actually love these situations better because it's literally what I call plug and chug. You're just going to plug everything in. B is 15 squared plus C is 10 squared minus 2 times 15 times 10 times cosine of 115 degrees. And this is actually awesome because I could type all this into my calculator at once. I don't have to solve for anything. The variable I'm solving for is already by itself, A. All I have to do is type in 15 squared plus 10 squared. I mean, you literally can't mess this up unless you just slip off your calculator and type in something wrong. 2 times 15 times 10 times cosine of 115 degrees. Please make sure you're in degree mode. And I get this answer. Now, before I go back to my work, this is not A, this is A squared. So there is one more step I have to do, and that is, of course, taking the square root of both sides. So I'm going to take the square root, and I'm going to go and grab all those decimals so I don't have to do any rounding in the middle of a problem, and I get 21.26. So A is 21.26. I do get a lot of kids that forget to take that square root. They just spend so much time typing all this into their calculator that they think that's their final answer. Please remember that it's the square root. Now, I do want to emphasize something that I've said several times is that anytime you take a square root, you got to consider positive and negatives. But this is an actual triangle, and you cannot have a negative side length in an actual triangle. So I don't have to explore that. All right, now that I know A, well, I guess I could go and use the law of cosines because I do know all three sides now, but that would actually be spending more time than you need because now I know both A's, I could use the law of sines, my best friend. So sine of 115 degrees divided by 21.26 is my magic ratio. I can't emphasize enough, any problem that starts off the law of cosines is going to go to the law of sines as well. It's easier. So my magic ratio is sine of 115 divided by 21.26. And I get 0.0426 as my magic ratio. Hopefully I'm going to write it down right this time. And then again, you can actually find A, B, or C. It doesn't matter. Once you find one angle, you can always find the other one very easily. So it's not like you have to do double the work. You just got to find an angle. Then you could just use geometry. So let's see. Let's find angle B. So sine of angle B divided by little b, which is 15, equals, hey, that same magic ratio. Multiply both sides by 15. So I'm going to multiply the 15 over to here. I'm going to pull the old switcheroo to solve for B, the inverse sine of 15 times 0.0426. Now I'm going to go back to my calculator, inverse sine of, and again, I'm going to use 15. Watch what I'm going to do here. Times, I'm going to go and grab all those decimals for accuracy purposes, and I get 39.75. So angle B is 39.75 degrees. All right. And I still have to find angle C, but there's no reason to do any trigonometry for that. We're just going to take 180, subtract away angle A, 115, subtract away angle B, 39.75, and I get 25.25 degrees for angle C. 25.25 degrees for angle C. All right, awesome. So good news is these are the only two scenarios where you need the law of cosines. Both I think are pretty easy. I don't think it's overly difficult. There is no ambiguous case where you're like, is there one solution, two solutions? The only time that happens is ASS. That has nothing to do with law of cosines. That's good news. Don't have to worry about it. Makes it pretty easy. All right, let's end by doing one more kind of tougher word problem. I do remember some of you guys struggle a little bit with these word problems, so let's go ahead and do this one to make sense of it. And again, we're going to be using the law of cosines. All right, a ship travels 60 miles due east. So straight east, a ship travels 60 miles. Then adjusts its course in a northeast direction. All right, everybody knows northeast. Hope you guys know that. Again, we're going to draw a picture of this in a minute, but just trying to read it through. And after traveling 80 miles in that direction, the ship is 139 miles from its original point of departure. What was the ship's bearing when it headed northeast? All right, let's draw a picture because as I've said, I don't know, maybe 15,000 times, a picture is worth 1,000 words when it comes to trigonometry. So let's make sure we get a real good feel for this. So we have a ship that starts right here. I'll put an S for start. And it goes 80 miles due. Actually, I'm going to erase this. You'll see why in a second. Let's start down here. Here's my start. And it goes 80 miles due east. There we go. 80 miles. And then at this point, it does change bearing. So I'm going to draw a little compass here. Having different colors is nice. And it's going to change to a northeast direction. So this is northeast. And it's going to travel for, I'm so sorry. I'm misreading my own problem. I'm so sorry. It travels 60 miles due east. Let's go back so I can show you that. 60 miles due east. Then after it changes direction, 80 miles in that northeast direction. So 60 miles due east. And then when it does go northeast, it does so for 80 miles. And then it says this is where the boat stops. This is the finish. And we know that it's 139 miles from its point of departure, from the original point. So it's pretty obvious that this is a side scenario. I mean, you can literally see the three sides. And what are they asking me for? The question wants me to find my angle that I changed course. So when I changed course, that's what it says here. What was the ship's bearing when it headed northeast? So when the ship decided to head northeast, what was its bearing? Now remember, the bearing is going to be northeast, right? You need the directions, but you also need the angle measured from the north. So this right here, that's why the picture is so important. This is the angle that I need to find. That is the angle from the north that the ship turned. Now, how do I find that angle? Well, I'm actually going to find this angle, because that is the biggest angle of the triangle. Again, it's across from the biggest side. So I'm going to find that angle. And now that angle is 90 degrees plus my bearing. So once I find this big dotted blue angle, I'm going to subtract 90, and what's left over will be my bearing, right? Got to be an engineer, guys. Got to think through these problems. All right, so I'm going to find this angle. I mean, this triangle does not have A, B's, and C's, so it doesn't really matter what you call it. I'm just going to call it B for sake of calling it something, and here I go. I know to find that side, or to find angle B, I'm going to do 139 squared equals 80 squared plus 60 squared minus 2 times 80 times 60. I'm going to squeeze this in times cosine of angle B. Now remember, when you use these formulas, I have them memorized, but whatever you're looking for here is the side across from it that goes over here. So if I'm looking for angle B, I got to put the 139 squared by itself. All right, now these numbers are going to be a little bit bigger, but you know what? Let's kind of be intelligent here, guys. Listen, like, you don't have to write down what 139 squared is. You could just do this, 139 squared. Don't actually figure out what it is, but I do need to subtract the 80 squared. And then I have to subtract the 60 squared. So, I mean, you're more than welcome to type in, or write in 139 squared, but it's just doing a little bit too much writing. Just use your calculator, right? So if I have that 139 squared, I subtract the 80 squared, I subtract the 60 squared, I get 9,321. 9,321. Now, what does this equal? Again, I got to first do -2 times 80 times 60. And I get -9,600. -9,600 cosine of B. And just like I stressed before, do not add 9,600 over. Somebody's going to do it. They're not going to listen, because this is not a 9,600. Looks like one, it smells like one. It's not. It's 9,600 times cosine of B. So to undo that multiplication to solve for cosine, I have to divide. So I get 9,321 divided by -9,600 equals cosine of B. Maybe that fraction can be reduced, but I don't even care, because I'm going to use my calculator anyway by pulling the old switcheroo. So angle B is the inverse cosine of 9,321 divided by -9,600. And I'm going to go right to my calculator. I'm going to do an old inverse cosine. 9,321 divided by -9,600. Close that parenthesis, and there's my angle, 166.15 degrees. So angle B is 116 point, I forget what it was already, 166, thank goodness I looked, 166.15, sorry, 166.15 degrees. I've never been good at memorizing numbers. All right, there we go, 166.15 degrees. Now, that's not my answer, because I want my bearing. Once again, my bearing is only the angle measured from the north. So drawing that little compass is super important. So again, if this entire angle, this whole big angle is 166.15, I do need to take that answer, and I need to subtract away the 90 degrees. And again, that's why drawing the picture is so valuable. And my bearing is 76.15 degrees. So that is this angle right here. And that is going to be my bearing. So my final answer, my bearing, when I decided to change northeast, was northeast 76.15 degrees. So please make sure you would write that answer with the N and the E, because the bearing does have the directions. Bearings are not just angles, it's angles with direction. So northeast 76.15 degrees. So pretty nice problem, pretty simple. Again, I didn't have to find angle S, I didn't have to find angle F, which again is the S and the F. Again, I didn't ask for those things. All I asked for was the bearing. So I don't have to waste any more time doing any more work on this problem. But again, essentially, this was just a fancy side problem. and be prepared for word problems where you don't have a right triangle. And we've dealt with this in the past, but it was always a lot of algebra work because we had to find a way to make a right triangle. Don't have to worry about that anymore. Now that we have the law of sines and law of cosines, we could do the math to solve right triangles and even non-right triangles, as long as you truly understand how to use these two laws. All right, guys, that's it for law of cosines. We'll close the book on it and work on some examples.